Now let's look at the derivative of a natural log. The derivative with respect to x of log of x is 1 over x. Now, you remember the log of x is defined to be the integral from 1 to x of 1 over t dt. So using the second fundamental theorem of calculus, if I take the derivative of this, then I get 1 over x. And of course, if I have a function of u, then it's 1 over u times the derivative of u with respect to x. So let's look at this one. There are two ways you can do this. I'm going to show you both ways. I can use the definition first. The derivative with respect to x of log of 2x is 1 over 2x times the derivative with respect to x of 2x. So this is 1 over 2x times 2, or 1 over x. The second way I can do this is to break this up using my log rules. So this is the derivative with respect to x, the log of 2 plus the log of x. Now this is a constant and goes away, and the derivative with respect to x of log x is 1 over x. Now I can't use that slick little rule with this one, but I still have to use the chain rule. The derivative of u is 1 over x squared plus 1 times the derivative with respect to x of x squared plus 1. So this is 2x divided by x squared plus 1. Now here I have a product. I'm going to have to use the product rule for this one. So this is x times the derivative with respect to x, the log of x, plus log of x times the derivative with respect to x of x. So this is x times the derivative with respect to x of log x is 1 over x plus log of x times 1. So this becomes 1 plus log of x. What about this function right here? Note, it is the entire log function is cubed. So I can't use any of the tricks. So I'm going to use a generalized power rule. This is 3 times the natural log of x raised to the second power times the derivative with respect to x of the natural log of x. So this is 3 times the natural log of x, quantity squared. The derivative with respect to x of log of x is 1 over x. So I can rewrite this as 3 natural log of x squared over x. You can write this as 3 natural log of x squared x over x, but that's a notation I don't usually use. Now what if I wanted to take the derivative of log of the square root of x plus 1? The first thing I'm going to do is rewrite this as the log of x plus 1 to the 1/2, and that is 1/2 the log of x plus 1. Now, when I take the derivative of f, this is going to be 1/2 times 1 over x plus 1 times the derivative with respect to x of x plus 1. Now you see how much easier this is than doing our square roots and whatever. So this is 1 over 2 x plus 1 times 1. Now what if I want to differentiate this? I can use the product and quotient rule, but why don't I rewrite f first as the log of x plus 2 times the natural log of x squared plus 1 minus 1/2 the natural log of 2x cubed minus 1. Now when I do f prime, it's 1 over x plus 2 times 1 over x squared plus 1 times 2x minus 1 half times 1 over 2x cubed minus 1 times 6x squared. So I can rewrite this as 1 over x plus 4x over x squared plus 1 minus, this is 3x squared, divided by 2x cubed minus 1.